Hi folks, welcome back to Math with Captain Rod. The purpose of this video is just to give a couple of examples here of application of the chain rule. I got two different examples written on the page. I'm going to go through them one at a time. So the first thing we're going to do is we're going to take the function y equals 5 cosine to the negative fourth power x, and we're going to find its derivative, y prime. Now, again, it's important to recognize there are two different functions here. There's a power function, something to the negative fourth power, and there's this cosine function. The outer function is the negative fourth power. So when we differentiate, I always differentiate outside in. We're going to have negative 20 cosine to the negative fifth power times x. That's coming from multiply the power, subtract 1. Now we move in and differentiate the inside function, which is cosine x, and the derivative of cosine x is minus sine x. If there was something in here, like maybe a 2x, we'd move in and differentiate that as well, but there's not, so that thing's done. This can be simplified. Let's see, minus is plus. How about we write this? 20 sine x over cosine to the fifth power x. You could leave it up top and write that cosine to the minus fifth x is just as good. Right. Example number 2 over on the right. So we're going to work on differentiation of this function now. So when we differentiate the sine function, well, actually, let me back up a little. When we look at this, it's important to realize there's two different functions here. The inside function is 3 pi over 2 times x. Then the outer function is sine of that. So differentiating outside in, the derivative of sine is cosine, so our first term is going to be cosine of 3 pi x over 2. That's the derivative of the sine function. Then we move in and differentiate the inside function, and the derivative of 3 pi x over 2 is 3 pi over 2. Next term. So cosine of 3 pi x over 2, again, two functions, the 3 pi x over 2, and then the cosine of that. Differentiating the outer function first, which is the cosine function. Derivative of cosine is minus sine of 3 pi x over 2. So the cosine part is now differentiated. Then we move in and differentiate the inside function, and the derivative of that is 3 pi over 2. And that's done. So I think what I'm going to do here is write down a couple more examples. Before I do, though, are there anybody have any questions about either of those? Well, let's try a couple more. So I am going to do what in this textbook is 34, where it says g of x equals tangent of 3x over x plus 7, the quantity squared. All right, so before we move on, some things to realize. One, the quotient rule has to be applied to this because we're looking at a quotient. However, when we differentiate the top, we have to chain rule it because there's two different functions, the 3x and then the tangent part. In a sense, there's two different functions down here too. There's x plus 7 and then that quantity squared. So really both of these are going to have to be chain ruled. So when we differentiate this, g prime of x equals. Now, we're applying the quotient rule, and to help anybody watching this, what I'm going to do is anything that's a derivative, I'm going to put in a hard bracket. So this is a quotient rule here. We need the derivative of the top and then times the bottom. The derivative of tangent is secant squared. So the first term is going to be secant squared of 3x. Then we have to move in and differentiate the inside function, and that's going to be just 3, so times 3. So this is the derivative of the top times the bottom. Minus. Now we have to differentiate the bottom. And again, the outer function here is the square part. So the derivative of that's going to be 2 times x plus 7 to the first power. So I'm differentiating the square part. bring down the 2, subtract 1 from the power. So that is the derivative of the bottom, and then times the top. Tangent of 3x. And then that's all over the bottom squared. So that's going to be x plus 7 squared, which is going to make that a 4. Now, this can be multiplied, distributed, and perhaps simplified. The differentiation of it is done. I'm going to go ahead and just call that example done. And I'm going to just start with a new one. Anybody have any questions about this one before I move on? All right. I'll try to find one that's got a bit more going on here. Oops. Well, here's one I kind of like. This is number 46 in the current text that I'm using here. It's written with t's. I like x's. I'm going to rewrite this. Y equals x to the negative 3/4 times sine x all to the 4/3 power. So quite a bit going on. The outermost function is this 4/3 power. So when we differentiate this thing, y prime equals, the first thing that has to be differentiated is this part right here. And that's just a pure power. So we multiply 4/3 times x to the minus 3/4 sine x. Subtract 1 from the power. If we take 4/3 minus 1, that's 1/3. So this part has now been differentiated. Now we move inside of here and differentiate. Now this is a product of two things. I'm going to do this here. So we got green and blue. All right, so when we apply the product rule now, derivative of the first is going to be minus 3/4 x to the minus 7/4. It's coming from multiply, subtract 1 from the power. So that's the derivative of green times the blue times sine x. Plus, now we're going to differentiate sine x and times x to the minus 3/4. So that's going to be times, or plus cosine x. That's the derivative of sine x times x to the minus 3/4. And I'm going to go ahead and just call that done. We could multiply, simplify, mess around with a little bit, but all of that is just cosmetic. This function has been differentiated as it sits. All right. So I think what I'm going to do is just call that video done at that point right here. And I hope that this video helps demonstrate how to use the chain rule differentiation. Have a great day.